We're going to have a look at LEDs. Now you can see two versions of the circuit diagram there. The one on the left, this one here, is the version that is used, that only shows you the pins that are actually being used. The one with all the pins labelled, including the ones that we're not using, and this is what your circuit diagram will look like when you create one for your assessment, has all the pins, but we're just using pin 3. Now, on my circuit board here, you can see that the ground wire and the 5-volt wire are already connected, and they should always be connected, and you should never remove them. Now, all LEDs require a resistor, and we're going to add the resistor first. So this is the resistor that we are going to use. Now you can see here that the resistor has the colours red, red, brown. That means it's the correct value. It's 220 ohms, and this resistor is the correct one for our circuit. So what we're going to do is we're going to add this resistor, and if you look at the circuit diagram, it connects to ground and it connects to the LED. So ground is this blue section at the bottom, so I'm going to put my resistor in there, and I'm going to put it into a random point on the breadboard. The numbers on the breadboard are irrelevant, I'm just connecting it in like that. Now this is my LED, and the LED, it matters which way you put it in. The resistor doesn't, but the LED does. So you can see from this LED that there are two legs, and one leg is shorter than the other. The shorter leg, as you can see from the diagram, is called the cathode, and that goes towards the negative bit or ground, and the longer leg is called the anode, and that connects to, well, it's towards the positive, but we are going to use that to connect to our pin on our Arduino so that we can switch it on and off. There is also, if you look at it this way on, there is also a flat side, which is here, which also points to the cathode and the negative end. So I'm going to take my short leg and I'm going to connect it into the same column as my resistor. So it can go here, it can go here, it can go here, as long as it's in the same column as our resistor. Now there's no connection across this middle part of the breadboard, so I'm going to connect it here, and then I'm going to connect across the gap like that, and I've got my LED connected to my resistor, connected down to ground. I now need one more wire, and this wire is going to connect it to our Arduino. So I place this wire. Now again, I can connect it anywhere in the same column. So the first one, I can go up one and go here, I can go here, I can go here, as long as it's in the same column. Putting it here, which is the same row, is incorrect. So here is incorrect, it needs to be in the same column. So I'm connecting it here, and now I'm going to connect it to pin 3 on my Arduino. Now for LEDs and like, you should never use pin 0 and 1. They can be made to work, but there's some extra complications that we don't want to worry about. So we're just going to connect it from pin 3 into our resistor like that. So let's make our LED flash. Now, so we need to look at code. Now, what we're going to use is this system here, where for our code, the blue bits come before setup, the kind of orangey bits are in setup, and the green bits are the various commands we can use in loop. We must use the blue and the orange bits. You don't have a choice about that, but which bits you use in the loop depend on what you want to do. So this is my this is what the software looks like. So I'm going to take this, and I'm going to take my first command, which is before setup. So this section here is the setup. So I'm going before setup, and I'm going to type int LED equals 3. Now what this does is allows us to refer to the LED as LED rather than pin 3. When you've got lots of things going on, you won't remember what 3 is, but you will remember what LED is. Now the first thing I need to do is set up the LED pin as an output, and I do this with the command pin mode. Notice the capital M. If you've got the case right, then you should see that the color changes, and it's an output, and again that's capital letters, and we finish the line with a semicolon. Now the LED, the word LED is a variable, and it can have any case you like as long as it is consistent throughout our code. So that sets our LED up. So we can do a simple turn on, which we could do with digital write LED high, and that's going to turn our LED on. So let's have a look and check that it actually works. I've plugged my circuit in. Now this button here is going to upload it. However, the first time I do it, it's going to ask me to for a name. So what I'm going to do is I'm going to call this Flash LED, or Blink is the usual title, but I've already got one called Blink, so I'm going to call it Blink 2. I'm going to save that. So I'm going to upload it, and we're going to get an error because what I haven't done is I haven't told it, oh, I have already, I've set up the port. If you don't tell it what port to do, it's not going to work. And you can see that my LED turns on. However, what we would like to do is make that LED flash. So what I can do underneath that is I can say I want to turn it on, so let's turn it off. So we do that with LED low, so it should turn on and then turn off, and because it's in the loop, it keeps repeating this forever and ever and ever and ever, and keeps going for on and on and on. So this should turn the LED on and off, and it should blink on and off. Except when you try that, it doesn't seem to work. If you notice, the LED might be a little bit less bright, but it doesn't seem to be flashing on and off. So what I actually need to do, the problem is that it's switching it on, then switching it off, and it's doing that so fast that you can't actually see it. So we need to slow it down, and we do that with the delay command. Now the delay is in milliseconds, so 1000 should make it delay for a second. So let's try that and see what happens. And I've got exactly the same. Now this is a common problem that lots of you will do. You put the delay and it keeps it on for 1 second, but when you turn it off, it loops back round and immediately turns it back on. We need a delay underneath the low as well, so it stays off for a second as well as being on. Most people remember the first delay but forget about this second one. So therefore, let's try this piece of code, and you can see that the LED turns on and off. Now if we want to change that and make that go a little bit faster, let's change this from 1000 down to 250 and try that, and you can see it blinks much faster. Now you notice when I changed that, I had to change it twice, once for the on and once for the off. Well, maybe you would, it's easy to forget one of them. So let's say if we only change one of them and did it like this. In this case, it's going to stay on for a second and go off very, very briefly. Now maybe that's what you want, but most of the time when you're doing something like this, you want both of them to be the same. So one way to get around this is to introduce a new variable that's going to be the time the LED is on and off for. So if we can say int pause equals, and let's make it 500 semicolon to finish, and then rather than 250, I'm going to use the variable I've just created, which is called pause. Okay, I'm going to run this, and you can see it works exactly the same as it was before, but what's really nice about this one is I only need to change it once, and I change it at the top of the page, and you can see it changes. I only need to change one number, and from that one number, rather than changing it twice, it automatically updates the rest of the code. So that's a nice way of doing it. It's not essential, but you can use that there to help you. So what we're going to do is we're going to use an online simulator which you can use from home, so you can do microcontrollers practice at home without needing to be in college or have the equipment. For the real assessment, you do have to create this using real equipment, but this is a handy tool for you to do some work at home. So what we're going to do is you're going to go to Tinkercad. This will need a username, an email address. You can use your college one or your home one. Obviously if you use the college one, that will stop working when you leave college. If you want to keep it, then please use your own email address. You might need a mobile phone number because it does two-factor authentication, so it sends you a text message with a code that you have to put in as well if you use a new computer, or if you have to if it's been a while since you've logged in. So what you want to do, it does do 3D printing stuff, which for models for 3D printers, but what we want is we want circuits. So click on circuits and then click on create new circuit. Now the first thing that it does is it gives it a very weird name. It's nonsense. It's got a whole load of adjectives and random words that it just sticks together. So the first thing we want to do is make it a sensible name. So let's call it Blink. Okay, so you just click up here, click on the title, and then you can edit it. And then we need to add some stuff. So first of all, we're going to change from basic to all, and then we need to add some stuff, and we're going to do that by scrolling down this section on the right hand side. And what we're going to need is we're going to need a breadboard. Now you can use either the breadboard or the breadboard small. For what we're doing, the small breadboard is big enough for what we need. But other times you might need the breadboard, so you can drag the bigger breadboard over and on top. If you want to get rid of something, click on it and then press the delete key, and that gets rid of it. We then want a microcontroller, so I'm going to drag my microcontroller over. Okay. Now before I add my next components, we need to set up the ground rail and the 5 volts rail, so I'm going to click on ground. Now what you can do, in order to, you can just click directly over here, but that can be quite messy. So if you click once, then it creates anchor points that you can then move around. And what this lets you do, and then I can move these points around if I want to make sure that's horizontal, that's vertical, and that's both horizontal and vertical, and I can just make it a little bit neater. So my 5 volts, I'm going to do the same thing with. Only this time I'm going to go all the way around the houses in order to avoid any other wires that I'm going to do. Now again, it may be worth, and then I'm going to click that there, nice and symmetrical. Nice. So I'm using the red one as positive and the black one as negative. So there we've got our power rails. Now we need a resistor, so I'm going to take my resistor and I'm going to drag it. You can see that you get little dots when it connects to holes, so I'm going to connect it here. Okay, now it's the wrong value. If you click on the resistor, you get this little box coming up. We want to change it to 220 ohms. So having done that, it then changes to red, red, brown, which matches what you have got from the in real life. We now need to add an LED. So if I scroll down, there's my LED. Now the LEDs unfortunately are not big enough in this simulator to run across this middle bit, so I need to put them in this way, which is slightly different to the way we do it on the board, but you can still see it works. Now on this one, if you move your cursor over there, you can see that one pin is called the anode and one is called the cathode. The cathode is the negative one that goes down to ground, and we want the cathode to connect to the resistor. We then have a wire, and it can go in again anywhere in this column, and then I'm going to connect that to, let's put that into pin 3. Now I should say in this, if you click on any of the wires, you can then change the color. So for example, I can make that red, and I can make this one black to match the bit it's going to. I don't particularly like black because it doesn't show up well in some places, so it's much better if I'm going to use blue, because I can see it much more clearly what's going on. Okay, and then I can match the colors here to the color of the LED. So I've got a red LED, so I could make that a red wire. But you don't need to, but that is just something that can actually help it and make it a bit easier to see what's going on. If I want to, if I click on the LED, I can change the color of the LED and make it yellow or blue or any other color that I like, but we're going to stick with the red one. Code wise, we click on where it says code. It initially gives us some stuff like this. We don't want to do that, although it may help you to start with stuff like this. What you need is this one here. It says text, and you just click continue, because in this is giving us actual code. So all I'm going to do at this point, you can type into here if you want to, and it works just the same. What I'm going to do is take the code that I already had. So I'm going to select the code here, I'm going to copy that, and then I'm going to highlight all of the code here, and I'm going to paste that in, and then I've got my code. Okay, then I can either hide my code or show my code, but I'm going to click on Start Simulation, and you can see that it works. Now it doesn't always work in real time. It's got a simulation time up here, and with something this simple it is pretty close to real time. However, when we get a little bit more complicated, it may run a little more slowly than the real thing might, but you can still see how it's going on. And I can stop simulation, and I can go from there. Okay. Now you can, if you want to, you can set this up. You can download the code, and that gives me something that when I double click on that, it will actually work in the real Arduino software. So it's saying it will ask you, it needs to create a folder. It's done, and there you go. So you can actually create that at home and then use the same software on the real Arduino. Now what we want to do is add a second LED. Now if I'm going to add a second LED, the first thing I need to remember is my resistor, and that's going to go down to ground. Check that it's red, red, brown again to make sure it's a 220 ohm resistor. Now I've got a green LED, but again I've got a short leg and a long leg, so the short leg connects to the resistor, which goes to ground, and the long leg goes over to the other side. And then I'm going to connect this, let's connect it into pin number 4. So my wire attaches to the same column as the LED there and goes into pin 4. So this time the first thing I'm going to do is I'm going to make sure that I've got keep my existing code. So I'm going to do save as, and I'm going to call it blink 2 LEDs, just to make sure that it's a different name. That way I can always go back to my previous version of my code if I mess things up. So the first thing I'm going to do is I need to go back to my before setup, and I need to define this LED. So let's call it int LED equals 4, apart from the fact I can't do that because I've already got an LED. So there are a number of options. I need to rename these. I could just call it LED2, but it might be more helpful to call it by the color. So let's call it green LED, and I'm using something called camel case, where every word that I use in this variable name I start with a capital letter. It just makes it easier to read. So I've got my green LED. That means this one should be red LED. Now I can just start replacing and type red LED here, red LED here, red LED here, and red LED here, which is okay, but I might miss one. A better way is to use the find function. So under edit, we've got find, which you can also use Control F, and I'm going to type in LED, and I'm going to replace it with red LED. It's because we're using code, it's better if you don't ignore case, and then we're going to do replace all, and now you can see that my LED has been replaced with red LED, and I don't have to worry that I've missed one. So the second bit is this in setup bit. So inside the setup, and inside means between this bracket and this bracket, and if you move your cursor over one of these, you can see that it highlights the second one. So underneath this, you'll notice that it's indented. The indenting, unlike Python, is not required, but it does make it easier to follow, so I would like you to make sure you do that. And you can see by clicking on the previous line and pressing enter, it will do that. So we've got green LED, that is also an output. Now we want to turn the LED on and off. We want to make it blink at the same time as the red one. Now usually people's first response to this is to do it like this: digital write green LED, comma, high, delay, pause, digital write green LED, low, delay, pause, and then we make it run. Now there is an error in this code. It is deliberate, but we'll want to see what happens. When I press upload, it gives me an error, and it tells me what the error is here, and it might give me some more insight down here, but it says green LED, and I say, oh, the case is different. I've had green LED with a lowercase e and d. So let's try that now. Okay. So what I wanted to do was them to flash at the same time, but you can see that it's flashing red and then green. But that's precisely what I've told it to do, because what it's doing is turn on red LED, pause, turn off red LED, pause, turn on green LED, pause, turn off green LED, pause. And that's what it's actually doing, because that's what I've told it to do. So what I actually need to do is I need to change that, and I need to make sure it does it at the same time. So to do it at the same time, I need to make sure that the things that are the same time are separated by the pauses. Things that are together without pauses, although they happen in sequence, that's so fast, it's millions of times a second, you won't notice it. So I'm going to take this and I'm going to cut it. So cut, and I'm going to put it next to the red LED, and then the bit where I'm going to turn it off, I'm going to cut, and then I'm going to paste, and I'm going to get rid of my extra pauses. Okay, now I hit upload, and it tells me, it gives me an error. Now what I did, I hope you saw what I did, is when I deleted those pauses, I also deleted my closing bracket at the end, and it's a closing curly bracket, okay, not a straight bracket. So I need to pop that back in, and it should work nicely. And now you can see that the green and the red are coming on what looks like in sync. The red will come on maybe well, certainly a microsecond or so before the green ones, but you can't detect that. So it looks like they're coming on and off and going in sequence. So let's make this in code. So I want another in simulation, so I want another LED. I'm going to move it over here because I know what's coming next. And then I'm going to add a resistor. Now I need to remember to change my resistor to 220 ohms. And this LED was green. So I'm going to run a wire, and that was in number 4. And it's a green wire to match the green LED. Here is my code. I'm going to click on the code window. I'm going to delete the code that's there. I'm going to use Control A to select all of the code, Control C to copy, and then Control V to paste that code in here. I'm going to press Start Simulation, and you can see it works the same here. What we'd like to do now is set this up so we can do some traffic lights. So again, I'm going to keep what I've got, and I'm going to change this, and I'm going to call this traffic lights. Okay, so for my traffic lights I need a third LED, and that third LED is going to be yellow or amber. So I'm going to put my LED in exactly the same way that the others were in, and I'm going to put it in the middle because I want the sequence to match the traffic lights. I want it to look like traffic lights. So I've got green, amber and red, and they're physically placed next to each other. Now if I was starting from scratch, I would probably have the pins in order, but I'm not, and I don't want to have to change what I've got. I want to add to it, so I'm just going to keep that as it is. And I'm going to plug this one into pin 4. Now, here's something extra we can do. Let's open the previous one that we've got. Let's open blink 2. Okay, now this just blinks one LED. What I want to do is I want to change this to pin 5, because it's pin 5 that I'm going to use on my yellow LED. So what this does is it checks that my LED was working. So if I'd made a mistake, for example, and put my LED in backwards, and then I couldn't figure out in my code why the yellow LED wasn't turning on when it was supposed to be, I would find out from running this that the problem was the LED was in back to front. So it's a good idea just to take some code that we know already works and use that to test that we've wired our circuit properly. And I can test each LED in turn using the same code just by changing which pin I'm connected that to. So I can test each LED before I come to my traffic light code. So, traffic light code. Now, I need to know what the sequence is. So I've got the sequence here. So my traffic light sequence is going to be red, red, amber, green, and amber. So the first thing though I need to do is make sure I've set up my amber LED. So int amber LED equals 5, and then I need my pin mode down here. Now, sequence is it starts with red. Now, what I would like you to do, it's possible to do this code by only looking at what's changing. However, if we do it that way, it's very easy to make mistakes and get a little bit confused about what's going on. So the best way of doing this is in each segment where we've got a pause. So each time we want to refer to each LED and say whether that LED is on or off. So what we're going to do, in the first place, the only LED that is on is the red one. The other two are off. And then I've got a pause. So what I'm going to do is I'm going to take that and I'm going to first of all test it, make sure that it's all working. And at the start, the only LED that should be on is the red. So what I'm going to do is I'm going to take this code and I'm going to copy it. So right click, copy, or you can use Control C. I'm going to go down below, I'm going to press the tab button to make sure the indent matches, and I'm going to paste this code in. So we've got paste. You've noticed I've left a little bit of a gap there. That just makes it easier to follow and see what's going on. So the second one at number 2, both red and amber are on together. And both red and amber are on together. Now I'm going to change this because it makes more sense to put them in order. Okay, I'm just using copy and paste there, and I'm using the keyboard shortcuts. So Control X to cut and Control V to paste. So in the second one, I want the amber, and I want the amber, red and amber on, but the green off. And let's test this. So we can see when it's uploaded that that goes red and then red amber. So the next one in the sequence is green on by itself, so I'm going to copy those 3 lines of code. I'm going to paste them in, and red is off, amber is off, and the green is on. Let's test this sequence. So I've got red, red, amber, green, and then we're back to the start again. And so we've got one more, which is the 4th one, which is just amber on by itself. So I'm going to copy that code, and I'm going to paste it in here, and this time the red is off, amber is on, and green is off. And let's test that, make sure it's working. So it's red, red, amber, green, amber, and back to red. And notice how I'm testing each segment of code, and that means if I make a mistake, I know exactly where the mistake is. I've tested my circuit first, I know all my LEDs are working, and as I'm only doing one little bit of code and adding it each time, if there is something wrong, I know exactly where that piece of what is obviously the bit I've just done, so I can fix it nice and easily. And I'm also setting up my testing that you're going to have to write about this, and make sure you write down that you've done it this way later, but for the moment we're just interested in actually making this work. So there is my traffic light sequence. Click on here to go back to my main window here. Now I want to copy this for my traffic lights, so I'm going to click on Options, Duplicate, and it's made a copy. Now instead of calling it copy of blink, I want to call it traffic lights. Oh, misspelt there, so go back in and edit it. Traffic lights. And now I need to add in my last LED. I'm going to make that one yellow. My last resistor. Okay. And I'm going to make that 220 ohms. I now need a wire, and that's going to pin 5, and I'm going to make that wire yellow just to make it a little bit easier to follow what wire's going where. Click on my code. I'm going to delete the code that I've got there. Let's go to the edit menu this time and go to select all, and then go copy, click in here, right click and go to paste, and then start my simulation, and you can see it's running through the same traffic light sequence. You can also copy and paste into your Arduino editor if you prefer, rather than just downloading the code and using it that way. So I'm going to stop the simulation. I'm going to click back here. Now let's say we want to take our traffic lights and we want to put it in our notebook so that we've got something to reflect back on, or we want to submit this as a piece of work that you want to give to me to mark. I need to do two things. So first of all, I click on this options box and click on properties. The first thing I need to do is make it public, and that means that somebody other than you can see it. So that needs to be the case, otherwise if you send me something I can't actually read it, I can't see it. So make sure you make it public and click save. Now we're going to click on this, and it gives us up in a window like this, and it will let us simulate it and it will let it work, but it won't let you edit in this mode. If you want to edit it, you actually need to click on Tinker This, but we don't need to do that. But this one just lets you actually run it and check it without actually opening it for editing. If you want to share it, what it does is it gives you a link here, so you can just take that link and you can copy it, and then if I want to put it into here, so if I'm going, you can do this into Word, I want to do this, so if I'm going in here I can click under here and I can right click and go to paste, gives me URL. If I then want to come and click on that, it will open up Tinkercad with my design, and I can either modify it or I can just simulate it here. So I can have a look at what you have actually done.